Welcome to this brief demonstration of moving your domain from another DNS provider to Amazon Route 53. This is part 1 of a series that demonstrates how to move your DNS zone, while part 2 demonstrates how to move registration services. In this demo we have the domain, movetoa53.com, that is currently with another provider. Our goal is to move both DNS zone services as well as registration services to Amazon Route 53. While we will be using Google Domains as an example for the current provider, the demonstrated steps are also applicable to other DNS providers such as GoDaddy or Gondi. Let's get started. First, we will provide a brief overview of the benefits of Route 53. Next, we will have a look at how DNS resolution actually works. This will help us better understand the steps involved for moving the domain, but it will also help us understand what could go wrong. Next, we will move the DNS zone for our domain. We will see steps both for using the AWS console as well as using the AWS API. Amazon Route 53 provides a good compromise between resiliency, cost, performance, and feature set. It is the only AWS service with a 100% uptime (SLA) on the data plane, meaning responding to DNS queries. Behind the scenes, the service is built on 4 independent stripes that help achieve this high resiliency. The cost for a registered domain is well in line with most other providers. With AWS, you only pay for what you use. As such, you will be charged separately for the number of used zones, the number of queries your zone receives, or whether you use DNSSEC or not. But these costs are very reasonable. Amazon Route 53 uses Anycast from currently more than 400 edge locations across the globe to provide authoritative DNS services. As a result, it is frequently among the top-performing DNS providers. Another huge benefit is the robust feature set, including various traffic steering capabilities. Last but not least, a solid API is available, which allows you to programmatically manage almost all components of the domain lifecycle. We will make use of the API in this demo. At its foundation, DNS allows us to resolve a hostname like www.movetoa53.com into an IP address. This is accomplished by a client, for example a browser, using a recursive resolver. An example for such a recursive resolver is Google Public DNS. Simplified speaking, the resolver will contact one of the root servers to start the recursion. While the root server doesn't know the answer for the entire hostname, it does know which top-level domain or TLD servers are responsible for .com and point the resolver to these servers. Similarly, for the next request to one of the TLD servers, the resolver receives an answer pointing towards the authoritative server for movetoa53.com. Finally, after contacting the authoritative server for movetoa53.com, will the resolver receive a response for www.movetoa53.com. From a DNS management perspective, there are 2 spots that as the owner of a domain we need to make changes. First, DNS zone management. The DNS zone management controls the actual entries in the zone itself. It includes creating, changing or deleting records like www or mail, which can be of different types like A, quad A, CNAME, MX, or others. While in the old days you actually had to set up a set of servers running DNS software like Bind, with the availability of DNS services like Route 53, you no longer have to worry about this undifferentiated heavy lifting and can focus on the entries itself. In the case of Route 53, you can thereby make use of DNS server distributed across more than 400 edge locations. Second, DNS registration services. The DNS registration services offer a few main components: the exclusive use of a specific domain name as long as you meet the legal requirements of that particular top-level domain, the ability to update the TLD server for our domain with a pointer to the authoritative DNS servers, and the capability to upload the DNSSEC public key for the specific domain name to create the chain of trust. In this first part, we will focus on the DNS zone management. Let's have a look at our initial DNS setup in Google Domains before we start making changes. As mentioned before, we will be using the domain movetoa53.com for this video. Here we can see a few important facts for this domain. We can see some typical zone records, including for example MX entries for Google Workspaces, also including DKIM public keys. And a CNAME entry for www.move-to-a53.com pointing towards a CloudFront distribution is also present. There is also an A record and quad A record present for a redirect of the Apex domain to www. The internally required NS and SOA records are also visible. DNSSEC is enabled for the domain. This domain is currently using Google Domains to manage the zone services. Let's have a look at what happens during a DNS migration. In step 1, we export the records from the current DNS into a format that Route 53 can understand. This format is the commonly used bind format that also many other providers use. While Google Domains can easily export the zone information of a domain in bind format, not every DNS provider can do the same. In a worst-case scenario, you might have to create the zone file manually by copy and pasting records from a web interface. In step 2, we create a new public hosted zone in Route 53. Afterwards, we will fill this initially empty zone by importing our bind formatted file. In step 3, Route 53 is able to serve DNS requests, but is not being used yet for the DNS resolution of our domain. Instead, the old provider is still being used. Nevertheless, this provides the opportunity to test the responses from Route 53 to DNS queries and validate that these responses are as expected. In step 4, after we have validated that the Route 53 public hosted zone is set up to our expectation, we can update the parent zone.com. After providing the parent zone with new name server records for our domain, which are the authoritative DNS server from Route 53, DNS resolution will use Route 53. The old authoritative DNS server can be removed after 2 days or 48 hours. Google Domains uses DNSSEC by default for domains that support it. In order to migrate a domain, DNSSEC must be disabled. It can be reactivated again after the migration is complete. You can see that disabling DNSSEC takes about 2 days or 48 hours. Google Domains will show the date and time by when this will be the case. While you can continue with the next few steps, we will have to wait for DNSSEC to be fully disabled before we can change the name server for the zone, which is the final step of the migration. There is no way to speed up this wait time, and if you choose not to wait, you will risk an outage of DNS resolution for your domain. Let's start by exporting our zone file from Google Domains. We can see the button Export DNS Records at the top of the page. Clicking on it will provide the option to download the file in bind format. After opening the file, we can see the same DNS records that we saw before. MX entries for Google Workspaces, DKIM public keys, and the CNAME entry for www.move-to-a53.com pointing towards a CloudFront distribution is also present. Next, we will use the AWS console to create a new public hosted zone and import the zone file. Choose Create Hosted Zone. In the Create Hosted Zone pane, enter the name of the domain that you want to route traffic for. In our case, it is move-to-a53.com. For type, accept the default value of public hosted zone and choose Create. Once the zone has been created, you'll automatically be placed inside this new public hosted zone. At this point, you will only see the NS record with the 4 Route 53 name servers as well as the SOA record. You are ready to import the zone file in bind format into Route 53. For this, select Import Zone File within the Records pane of the public hosted zone in the Route 53 console. Next, copy and paste the entries from the zone file in bind format into the window that opens. You will see all records that Route 53 was able to identify within the zone file displayed. One record that Route 53 is not able to identify is the 2048-bit DKIM record. This can quickly be fixed by removing the white space between the two chunks of 255 character text. Once that's done, you will also see the corresponding text record type entry. Once everything looks good, click on Import and Route 53 will create all the records into our public hosted zone. After a few seconds, our zone is ready and can serve traffic via the Route 53 authoritative name servers. But at this point, nobody other than us knows yet about this new zone on a different authoritative name server. If you prefer using the Route 53 API, for example because you want to do this process for hundreds of domains, you can look at the very valuable open-source command line tool for Amazon Route 53, called CLI 53. You can even run it without any issues with an AWS Cloud Shell. Just download the latest release for AMD 64, make it executable and you're ready to run it. When running CLI 53 in AWS Cloud Shell, AWS credentials are already pre-configured. First, we create a new public hostess zone using CLI 53. With AWS Cloud Shell, you can quickly and easily upload the zone file in bind format via Actions Upload File. Then we import the zone file via CLI 53. Afterwards, we can check in the AWS console that everything was correctly imported. We can now use the well-known DNS tool, Dig, to test the new public hosted zone in Route 53 from within Cloud Shell. Using the @sign, we can specify one of the new authoritative name servers to be queried. But doing so manually against every record in our zone file is very cumbersome. It is also error-prone to compare the results manually. Instead, we will use the open-source tool DNS Compare to automate this step. The tool can also be easily installed in Cloud Shell. If we compare the bind file that we actually used for our import, we will see that DNS Compare did not discover any mismatches. On the other hand, in case we use a bind file that was altered and includes mismatches, the tool does discover them. We are almost done with moving the DNS zone to Route 53. As a last step, we need to update the name server for our zone within the parent zone.com. Make sure to only commence with this step after the 48 hours for disabling DNSSEC in Google domains have completed. Within Google DNS, we select Custom Name Servers and then Manage Name Servers. Next, we need to enter the 4 Route 53 authoritative name server that correspond to our zone. We can easily find this information in the Host Zone Details section. Just copy and paste the values and select Save once you are done. If all the Route 53 authoritative name server have been entered correctly, you can select Switch to these settings. After a few minutes, you can use Dig again to validate that the parent zone has been updated and now responds with the Route 53 authoritative name servers. It will take up to 2 days or 48 hours for this final step to complete. During this time, you should not make changes to your zone records or delete the zone with your old DNS provider. As an optional step, you can now re-enable DNSSEC for your zone. For this, you need to enable DNSSEC signing of the public hosted zone in Route 53 and establish the chain of trust by uploading the delegation signer record into the parent zone. This delegation signer record or DES record allows resolvers to validate the child zone's public KSK or key signing key. Let's start by enabling DNSSEC for the zone in Route 53. Within the public hosted zone, select DNSSEC and then click on Enable DNSSEC signing. Next, provide a name for your key signing key and either choose an existing customer managed key or create a new one. Here we will create a new CMK and give it a name. Once done, click on Create KSK and enable signing. This process will take a few seconds to complete. After the DNSSEC signing has been enabled, you can look up the information to create the DES record. These information have to be provided through the registrar services to the parent zone, which is currently still done via Google Domains. The information that Google Domains requires are key tag, signing algorithm type, digest algorithm type, and digest. Within Google Domains, select Manage Records in the DNSSEC section and fill out the required information by copy and pasting the values from the Route 53 console. Once complete, select Save. If you prefer using the Route 53 API, for example because you want to do this process for hundreds of domains, you can do so as well. First, you create a new key signing key, using an existing customer managed key. It is also possible to create the customer managed key via the API, but we are not showing this here in this particular example. Note that the information of the DNS record for this zone signing key are displayed once the command completes. Remember that you need this information for updating the parent zone to establish the chain of trust. Next, you enable DNSSEC signing this zone. After a few seconds, the status will change to signing. You can either reuse the same customer managed key for multiple key signing keys or create separate customer managed keys. Lastly, you can optimize some of your DNS records by converting CNAME records to alias records. In our example, a good candidate to do so is the CNAME record for www, which can now be converted in 1A alias record and 1 quad A alias record. This will speed up DNS resolution for these DNS records. This concludes part 1 of our demo video. Also check out part 2, which walks you through changing the registration services of your domain to Route 53. If you liked this video, don't forget to click on subscribe. You can also head over to www.edgecloud.net to find more interesting content. Thank you for watching.